The presentation that I want to give you today is about the use of digital footprint data for human mobility. So I want to focus on what's been done so far and what are the key challenges that I think are going to shape the agenda in this space in the coming years. So for those of you who may not know me, so I'm Franscisco Rowe, so senior lecturer in quantitative human geography at the University of Liverpool. I am also the lead of the Geographic Data Science Lab at the same institution. So I guess moving on with the presentation, so the work that I'm going to be presenting today, so it's part of two different publications I have. So here are the titles and the QR codes in case you wanna read a bit more about this research. So one of them, so on your right, so it's a report that we wrote with a number of different experts for the Alan Turing Institute in the UK. And that is much more focused on human mobility, whereas the other piece of work is generally speaking about the use of big data or digital footprint data for human behavior, more generally speaking. So before kind of jumping to the actual core bits of the talk, so I think one of the things I wanted to get across is the complexities of capturing human mobility, so measuring human mobility. So it tends to be a quite complicated process. So when we talk about human mobility, right, so we get at least 2 points that we are considering. So the relationship in a space between 2 points, the origin and the destination. So, but then there is also the direction of a flow or of a movement, which adds a third dimension. And then when you start adding time and the mobility of people between places in a space, then adds a lot more complexity. Then you got time and you got different locations that you want to be able to understand. So having that in mind, the way how we've been capturing human mobility has evolved over time, and with the rise of digital technology and big data, so we now have many different data sources that we can actually employ to capture human mobility. Over the last few years, so there has been lots of progress using mobile phone data to understand human mobility. So in general, there are 4 different data sets or 4 different sources that are used to capture human mobility. So you got CDR or XDR data, which refer to the call details records. So on that, they give you point data that you can link to different antennas close to the position of people to track human mobility. So you record the location, and by compiling a series of records, so you can get an idea of how people move in a space. So those sort of data tend to be quite high level, I mean, in comparison with other data sets, and they normally give you a coarse sort of temporal resolution. And again, that is in relative terms. Then you also got GPS data, which probably provides a lot more information about the trace of human mobility. So they could capture data points at regular intervals as people move. And then more detailed data can be obtained from the processing of Bluetooth signals on mobile phones. They give you information that is very, very detailed and in frequency, but also in terms of the geolocation. And they are normally being used to also look at movement within buildings. So it's very, very precise information, though it's less available compared to other data sets. And then you also got smart car data. So data that you get from normally from public transport when you go on a bus or ferry, and then when you get off from the service. So you get 2 points locations that you can track then and try to understand mobility in that way. And also, I guess not included here is the card transactions. So now people using credit cards or debit cards. So those data have been also used to track mobility and also consumer behavior patterns. So I guess something to say about all of this, which is very important, is that all of these data, although they've been used and they are very helpful to look at mobility and measure mobility in very short time intervals, they haven't, I mean, the principal purpose is not research or analytics. So it's just the research process and the way how these data have been used to support decision-making processes is a byproduct. So, and that is something really important, because as I'm gonna tell you now, so there are quite a lot of different challenges that entails. The first challenges so relate to so ethics and privacy. So one of the first things, right? So it's anonymization of the data. So although we have very high resolution data, so we always need to take care of privacy and confidentiality because this data, the main purpose, as I said, is not research. So when people sign up for contracts on mobile phones, they are not expecting that the data are going to become available, at least not at the individual level. So there are different ways on how companies and academics have been looking to ensure that we try to strike a balance between the loss of the privacy component and the accuracy of the data. However, as we have discovered, there is a trade-off between those two components. So the more accurate the data are, the less privacy you have. And on the other hand, the more privacy you're trying to ensure, the less accurate the data are. And there are some good examples looking at the data that are being produced in the US. So they've been trying to increase the privacy component, so that make the data more confidential. However, what that has been leading to is that the data that they are available now, at least for some locations, they tend to be less accurate. So then there are lots of questions around, so to what point or to what extent we need to ensure privacy. So what are the right levels of privacy that we need to ensure, or sort of what level of geography and temporal resolutions. So finding a balance in this curve that you can see in front of you, so it's something that we need to work, and probably we need to develop standards to make sure that we know what sort of levels of privacy are needed to ensure confidentiality of individual records. So another thing here that is important is that because of the data, they are not freely available for anyone to use. Actually, the accessibility to the data is quite different across different populations, across different institutions. And one of the issues is because companies tend to own the data. One of the problems is that the data cannot be shared. So once you have worked on the data, you have run analysis on the data, so the data are not available for other individuals to be able to replicate the analysis. So there are lots of questions of what can be done in terms of making data, synthetic data available, so people can be able to replicate and reproduce analysis, and also validate the analysis, which is another component that is very important here. So the other big challenge relates to data issues. So as I already kind of anticipated, so one of the big issues is inequalities in terms of access and discoverability of the data. So we don't have clear guidelines or standards on who can access the data, how people can access the data. So in some cases, there are individual data sharing agreements on how people can access the data. So there are other companies that are opening up a bit more the data to at least some academic institutions like Facebook or Meta now through their Data for Good initiatives. Google and Apple during the pandemic, they made data products available so different governments and people could track the evolution of people meeting the local requirements given lockdowns and quarantines. But there isn't a standard data sharing framework that ensures wider accessibility and discoverability to the data. And I think that is something really important. So everyone in the community can benefit from analyzing those data, not only analyzing the data, but also the implications that may have in society. Another issue that we tend to find with the non-traditional data sources from mobile phone data is that what you get, right, from mobile phone data, so you get the location, an X and Y coordinate, and in some cases, so if you got a temporal series, so you tend to get a timestamp. But that's it, right? So, and normally what you want to be able to get is to be able to understand some process that is associated with mobility. As in the case of the pandemic, for example, there was a lot of interest in looking at how the relationship between mobility and COVID infections was spreading. And so here in the UK, so there were many studies that wanted to connect the two dots. However, it was really difficult because of data and policies around the data. So they weren't in the same environment, digital environment. So you have the mobility data that are sitting on a company digital environment where you can analyze and process the data. However, you cannot infuse or ingest new data in that environment to be able to analyze health outcomes. And in the same way, where the health data are collected or stored, so they are separate from where the mobility data are sitting. So it's really difficult then to integrate data, and that so hampers the process of interoperability of the data sources. And I guess, get the questions that we are really trying to answer here. Another issue is that we know that digital trace data, they got different biases depending on how data are collected, and so whether the data are being collected from a particular population like Facebook or Twitter or a particular other application. So you tend to have different biases in terms of the social, demographic dimensions of the population. So what we know is that we tend to collect a lot more data from people that characterized as being from urban places, highly educated, wealthy, young, and in the middle age brackets. And that is because there are two different biases that are usually introduced in mobile phone data. So one bias or one source of bias is differences in the access to technology. So access to technology is not equal across populations, and that tends to create biases. So we tend to capture a higher frequency of certain populations. And the other bias has to do with differences in the use of technology. Yeah. So one thing is access, so having a mobile phone, for example, and the other has to do with whether and how frequent you use the mobile phone. So if you have it, there are people that are more limited in their use, and sometimes that also introduce biases in that way. So you have the cases where less wealthy individuals tend to use the mobile phone less frequent because they have more limited data plans. And that issue tends to create biases in the way or the information that is collected from those mobile phones, because the data points that you are going to get are probably going to be less frequent than someone from a wealthy family. So, and that is another issue that got to be tackled, but it's a real challenge. And the third big challenge has to do with methodology. So there is a lack of standard practice, particularly on how you process mobile phone data. So if you have ever seen mobile phone data, they tend to be very unstructured, and there is a lot of pre-processing that need to be done, or data engineering that gotta be done before being able to generate a data product to analyze the data. But there is a lack of standards on different crucial decisions of what you end up considering within the data. And that is a real challenge. Another challenge is how you validate different models within the framework. Second issue within, or a second methodological issue, is the generalization of the observed patterns. As I mentioned earlier, right? So there are biases in the data. So then there is a question on how we can tackle those biases in a methodological way, not improving the data necessarily, but then how we can factor in different ways in the methodology to capture those biases. And there are different ways how people have been looking at this. However, there is no clear approach on what is best. So there are people, for example, that have been using census data to resample or reweight the data from mobile phones. However, the problem with censuses is that censuses in many countries are taken every 10 years. So, and one of the advantages, right, of mobile phone data is that you can track mobility in real time. But then if you are using data from censuses that were taken 5 or even 7 years ago, so it is questionable whether by reweighting the mobile phone data, you are actually achieving or making any good to the data, because essentially what you're doing is taking the data 7 years back in time. Yeah, so there are lots of questions on whether that is a good or the right approach to do that. And that is why I guess that is an active area of research at the minute. Another issue is, so as I mentioned earlier, so what you get from mobile phone data is usually the X and Y coordinates and an ID for the device. So, but then the interesting components that you want to be able to understand usually relate to the population and places, right? So where people move, what sort of places they move, and what sort of population moves and use different services. So there are lots of questions on how you can then start integrating different data sources with mobile phone data, and what is the best process to do that. So the way how it's being done, right? So it's trying to look at individual data points and looking at different layers of land use, for example, so POIs and how they intersect, and then you can get an understanding of what sort of places people tend to visit. So a bit more difficult has been adding information about socioeconomics and demographics to the data. Normally, the way how it's being done is being taking an area and looking at the populations living in those areas from surveys or censuses, and then adding that contextual information to the data points obtained from mobile phone data. Ideally, what you want to have is individual level information of peoples, right? So not only the context, but also the people moving across different locations, and that is something that I think needs to be a bit more work done, and is a current challenge. I guess to start summarizing all of this, so no traditional data sources, digital footprint data, they offer quite a lot of opportunities to understand human mobility and different dimensions of human mobility, given that it's quite instrumental across different areas of society, transport, health responses, urban spaces, and so on. However, there are still ethical, data, and methodological challenges that we first need to address to be able to actually leverage on the potential opportunities of mobile phone data or traditional data sources, non-traditional data sources. So a few of the things that I could argue need to be done is develop protocols for ensuring fair data. So that means findable, accessible, interoperable, and reusable data sources, and also generating in the cases where the data cannot be shared or cannot be accessed post-analysis. So it's the case of synthetic data that can be served to replicate or simulate analysis that have been previously done. Another thing is the development of what are called trustable research digital environments, where you can have data sources from different providers, and then you can use the digital environment to integrate data. So then in the case I was mentioning earlier, right? So usually you want to integrate the data from mobile phones looking at mobility with data from different health outcomes. So you have a trusted research digital environment, you should be able to do that. Another thing is, right, assessing and correcting biases regarding the process of data generation or usage. And finally, so it's probably it's a resource that I think should be made available, identifying a standard, I guess, what is good practice in terms of tools, but in terms of methodology, also about the data engineering process and validation of the data to ensure that we are capturing so the mobility processes that we meant to be capturing. Well, thank you. Here I leave you the QR codes in case you are interested in the papers I mentioned earlier. And thank you for listening. I'm happy to answer any questions.